Hey, let's do another redox reaction here. I wrote it down, and then we'll just kind of take our way through it. And so, what happens here is obviously we're getting it looks like a reduction on the chromium and an oxidation on the sulfur, and we can figure that out. So, oxygen, you got 4 times -2, so that's going to be -8. And then it's a -1 overall, so you figure out the chromium is a +7. And then the sulfide ion, it's just a -2. And then the chromium 3 ion is going to be a +3, so chromium is reduced. It goes down. See, when it's in this polyatomic, it's a +7 oxidation state. Here, it's a +3, so it's been reduced. It's actually gained electrons. And then the sulfide, oh, well, look at that. So it's SO4 -2. I'm just going to check yeah, okay. So wanted to make sure I copied that down right. And so, again, you've got 4 times -2, because oxygen's a reliable -2, is -8. Here it adds up to -2, so the sulfur is going to be a +6. So that's a big swing there. The sulfur is oxidized up from a -2 to a +6, so oxidation is a loss. So the next thing we do is we divide up our oxidation and reduction steps. It doesn't matter which one you do first. I always tend to just put oxidation first. I don't know why. So my oxidation is going to be S minus 2 SO4 -2. I'm going to give myself just a little room. So I'm going to work on this oxidation here. And I had reduction written there, but I'm going to give myself some room, So the issue here first is you balance everything that's not oxygen or hydrogen. So look here, boom, 1 sulfur, 1 sulfur. Don't worry about charges yet, that comes later. So 1 sulfur, 1 sulfur. So now I got to work on these oxygen. So the only way to add oxygen is to put water in. So since I have 4 oxygen, I'm putting in 4 waters, 4 H2O. Okay. So now my oxygen is balanced, but I've got all these hydrogen. Okay. So I got 8 hydrogen. Oh my gosh. Plus 8 H plus. Okay, and so now I've got a situation where I've got a -2 here, I've got -2 here, and I got 8 pluses here. And so my problem being is I need both sides to be -2 because the charges need to be equal. And so I'm going to add 8 electrons. Okay, and so that is a balanced reaction there. Everything balances out, including the charges. It's a -2 here and a -2 here. Guess I didn't need to mark out the reduction. It wasn't that much room, so I'm just going to rewrite it. Reduction. So my reduction, CrO4 -AQ. And then what I do try to do is keep the arrows lined up, because that, oh man, if your arrows here and there, it's hard to tell between the reactants and products. So in this situation, I've got a problem here where my chromium is balanced again. So the water is going to go over here, which puts the hydrogen over here, and you're going to see how that works here in a second. So again, it is 4 waters to balance out those 4 oxygens. And then to balance out the hydrogen, it's going to be 8H plus. Okay, so we added the 4 waters, the 8 hydrogen, and then now I'm at a point where I got a +3 here, and then a +7, so I'm going to have to add 4 electrons right here. And we should be adding the electrons on the reactant side because it's a reduction half reaction. On an oxidation, the electrons are always going to be with the products. On a reduction, they're always going to be with the reactants. And if you remember that, that might save you from making mistakes here. So, I've got an oxidation step and a reduction step. So this is balanced and this is balanced. My only problem is I've got 8 electrons in the oxidation and only 4 in the reduction. So I'm just going to double my reduction step real quick here. So that's going to be 16H plus 2CrO4 negative plus 8 electrons yields 2Cr plus 3 plus 8H2O. Okay, so the reason I did that step was so that I would have 8 electrons to cross off with 8 electrons, and you always want your electrons to cross off. So now I'm going to write my 2 steps here. And then I'm going to line up my arrows because that helps me cross off my reactants and products. Plus 2CrO4 negative plus 8 electrons, 2Cr plus 3 plus 8H2O. Alright, and then I usually like to put like a line there, okay? Just so I can tell. So now I can start crossing off. And obviously the first thing I can cross off are my electrons. I got 8 as a reactant from my reduction step and 8 as a product from my oxidation step. So those 8 electrons, bye-bye. And then I got 4 waters. I got 4 here and I got 8 here, so I can't cross all of them off, but I can get rid of 4. So that's going to be 4 waters gone, and I'm going to have 4 left. That's good for me there. And then I've got hydrogen ions that I can cross off. And again, I'm not going to be able to get rid of all of them, but I'm going to be able to get rid of some. So I have 16 here and 8 here, so I'm going to cross off those 8. The 16 becomes 8 because, we've gotten rid of 8 of them. And that's it right there. And so I got 8H plus S negative 2 plus 2CrO4 negative yields SO4 negative 2 plus 2Cr plus 3 plus 4H2O. Did I get everything in there? Yes, I did. And then, if you wanna make it, that the 8H plus, those are in aqueous solution. The sulfide ion is going to be in aqueous solution. The 2 chromate ions are going to be in aqueous solution. The sulfate ion is going to be negative 2, is in aqueous solution. The 2 chromate 3, chromium 3 now. Chromate has the oxygen in with it. That's going to be an aqueous solution, and the water's just going to be a liquid. Okay, so that is balanced perfectly in an acidic environment, okay? And so if you want to do that in a basic environment, you just add enough hydroxide to both sides, which would be 8 to cancel out the acidic part, and I'll do that here on a separate sheet so as not to confuse things. See if I can recycle a bit of paper here. So 8H plus AQ plus S negative 2 AQ plus 2CrO4 negative AQ arrow SO4 negative 2 AQ plus 2Cr plus 3 AQ plus 4 H2O liquid. Okay, and so if I just add the 8 hydroxides to both sides, that makes 8 water, which, pay no attention to that. So right here, I add 8 hydroxides to both sides. And that makes that water, 8 water, and now I got 4 water over here. So that water cancels out. I got 4 water left over, and then I just write it 8, or dang it, 4 water liquid plus S negative 2 AQ plus 2 CrO4 negative AQ yields SO4 negative 2 AQ plus 2 Cr plus 3 AQ plus 8 OH negative AQ. And so that's how you flip it into a basic environment. And you don't need to, we'll understand more about that as we get deeper into acids and bases. But just remember, this is what makes it the acid, those H pluses, of course. And then to flip it, you just add enough OH to cancel it out.